So this is the fourth part of the video, and this is, so far you have learned about what data and information are, what data structures and algorithms are, the difference between static and dynamic structures. Now we'll put it all together and with the concept of time versus space trade-off, which is the most important ideas in computer science. Then I'll list the advantages of data structures, give a concise summary, and end with a quiz. Time and space complexity. Time complexity means how fast an operation runs. We measure it in terms of the number of basic steps, not actual seconds, because seconds depend on hardware. But for comparison, we use week or notation. The space complexity, how much memory an algorithm or data structure uses. For example, an array of n integers may take O n space. We will discuss them later in detail. Now the golden rule is, the faster often means more memory, less memory often means slower. So let me go to the advantages of data structures. Here are the 9 main advantages of using proper data structures. Efficient data organization. No more messy room. Everything has its place. Faster searching. We have separate data structures for searching, like binary search instead of linear. Reduce time complexity. Your code runs in milliseconds instead of minutes. Efficient memory utilization. No wasted space. For example, in a linked list only uses memory for nodes you actually need. Reusability. Once you implement a stack or a queue, you can use it in many different programs without rewriting. Abstraction. You hide the complex implementation details behind simple interfaces. Users of your data structure don't need to know how it works inside. Solve real-world problems, from GPS routing like in graphs to database indexes, and to do undo or redo operations. And it's a foundation for algorithms. Most algorithms are designed to work on specific data structures. Sorting algorithms often assume arrays. Graph algorithms assume adjacency, list, or matrices. The final advantages of data structures is improved code clarity. When you use a well-named data structure, other developers immediately understand your intent. Every software engineer uses these advantages daily, so these are really important. So these are the things what we discussed so far: data versus information, data structures, algorithms, and static data structures, dynamic data structures, and the trade-off. let's test your knowledge. Please think about your answers before I reveal them. Pause the video if you need more time. The first question is, you are building an undo feature for a text editor. Which data structure is best? The second question is, you need to store 1000 student records and search by ID very frequently. Which is better, array or linked list? Now I will answer the questions. For the first question, the answer is stack, because the undo feature follows last in first out principle. The most recent action is undone first. Stack push, that means add, and pop, that means undo the last action operation exactly match the behavior. An array could be made to work, but you would have to manually track the top index and shift elements, more complex and less efficient. A queue won't do this. And for the second question, the answer is array. Even if you don't know the exact index, you can sort the array by ID once, then use binary search to find any record. So the answer is stack and array. We will go into deep dive into these data structures in later sections. For the time being, these are the answers.